We want to be able to find the inverse of a one-to-one function, okay? First off, I want to show you some notation here. If f of x is what I'm using as my original function, then the inverse is going to be written as whatever that function name is, f, with a superscript, an exponent of -1. I don't read it f to the -1, I read it as f inverse. So when you see this little -1 exponent, that's referring to the inverse of a function. Now what are the steps for actually finding that? Well, they're all pretty easy except maybe number 3 gets a little complicated. We're going to replace our f of x with a y just because it makes it easier. We're going to switch our x's and y's because that's what inverses do. They reverse that process, right? And then we want to solve it for the y, and then we're going to replace the y with that new inverse notation. Let's take a look at a simple, straightforward example. If f of x is equal to 3x plus 2, and they're telling me it's 1-to-1, so I know that when I find its inverse, it will again be a function. That shouldn't be a surprise. This is a line, right? And as long as it's not a horizontal line, it's going to be 1-to-1. So first step, replace f of x with y, then switch your x's and y's, and then solve for y. So to solve for y, we'd subtract 2 and divide by 3. And then I put in my new notation here, f inverse of x is equal to the quantity x minus 2 divided by 3. Now if you're taking a test and you want to just verify that this really is the correct inverse, what I might do is put that in my calculator. So if I scroll down, show you my y equals, I got my original function there and my what I think is the inverse. Now note how I put in the numerator here. I did have to put it in parentheses so that it knows to divide all of that by my 3. Then when I graph it, I can see, or I should see, that if I fold it along the diagonal line, y equals x, right through the 45-degree line here, that these pictures would line up with one another. So I'm convinced that we did do the right thing. Okay, let's take a look at a little bit more complicated examples here. We want to find f inverse. So f of x equals 7 minus x cubed. First thing, replace f of x with y. Then we switch our x's and y's, and then our job is to solve for the y. So I'm going to add the y cubed over and subtract the x over, and then to get just y, we'd have to undo the cube by the cube root. I don't have to worry about plus or minus here, so I get f inverse is the cube root of 7 minus x. If you were to put both of these in your calculator, you would again see that it's a reflection along that diagonal y equals x line. Now what about this next one? This is a fraction. This tends to give students some problems just because of the algebra involved. First off, replace f of x with y, switch our x's and y's, so far no problem. But if you have a fraction, remember to make it go away, you multiply by the common denominator. So we're going to multiply both sides by y minus 2, and that would cancel over here, and over here we get the x times that. Now I divided through by x. You could have distributed if you wanted, but I went ahead and divided the x away because I don't want that. I'm going for the y. And then I would add my 2. And so my final answer here would be 7 over x plus 2.